Hey guys, it's me, Christina Wynn, and today I'll be talking about my Physics 2211 Lab 4. So a brief introduction is that we will compare the predicted and observed oscillating motions of a mask attached to a spring as our purpose, and we'll be using glow script as well as tracker. And then some fundamental physical principles we'll be using in this lab is Newton's second law and the energy principle, and some representations of the energy principle is that, to sum it up, the change of energy is basically equal to work, and we could separate energy into its core components. So basically change of kinetic energy plus change of potential energy, which I will just put as mg, change of h, and then change of spring energy. So s squared minus si squared. And then since work is 0, there's no work being done on the system. This will be basically our equation that we'll be working with in this lab. So some reasoning for assumptions, we have to set the system to include all elements because then this equation would not be true if we do not do that, because as you can see, we used internal energy. And then the only energies in this system is kinetic potential and spring. So here's just a preview of the main results. And then for the surroundings and system, there are no surroundings, but the system would be the mast and the spring and the earth. And then here are the initial conditions. Okay, so here's the experiment, and this is just kind of screenshots of it. So here's just a screenshot of the video, a screenshot of what we got for the graph results, and I will be showing this again later in the video because we'll be using this to talk about the discussion question. And then here's just a chart of all the data, and we used kind of the top two or the beginning two into our computational model. Okay, so now we're on to coding, and we'll be talking again about the initial conditions. So here are the initial conditions. As you can see, 0.117 and 0.609 matches up with the data we found in the experiment. And then relaxed length of LO is equal to 0.123. Now I'll show you guys how I calculated that. So basically I moved around some variables in the spring potential energy to get LO by itself, and we basically calculated it with these values. And then for the rest of the code, we basically use kind of like I showed in the beginning of this video, the basic energy principle, but like in all kinds of different variations. So we basically get the sum of the energies all together and then use that to find the position. And it's just basically, you know, just using the principle to get to what we want, which is the position. So here's just all the formulas, and then these formulas are basically the how we get each energy. So we get kinetic energy, gravitational potential energy, and spring energy with these formulas. Okay, so some similarities and differences. As you can see, they're quite similar. They don't really differ too much. I mean, there's a slight gap here and there, but it's not too bad. As you can tell, they're very, very closely matched up. So some possible sources of error or some possible sources of these gaps would be the assumptions that we had to make in the beginning of this video, as well as some rounding errors and some approximations for each delta time interval. So each time when we're doing the computational model, we're assuming that something remains the same for a time interval, which is usually not the case. Okay, so what if and what does it mean questions. So as you can see right here, this is the computational model, graph. Now, I would say my graph particularly does not exactly match with the energy principle because there are slight bumps here and there, but I would say it closely matches up as it is very linear. So I would answer this question with yes, it does follow the energy principle of being at 0 or being just conservation of energy, basically is what I'm trying to say. And then for right here, what does it mean? So for the time intervals, I calculated this beforehand, and I got 1.614, 1.615, and 1.709, and we averaged that to get 1.646 for the x period, and y is very closely followed with a basically just like around 1.5-ish, which is really, really close, surprisingly. So that's awesome. Okay, so some conclusions. So here's just basically the conclusions page. Thank you so much for listening to my presentation, and yeah, I hope you have a good day. Bye.